Yeah, thanks a lot for the nice introduction, Madeleine. And hello, everyone, to our talk, How to Develop Your First Cloud-Native Applications with Java. In the next 30 minutes, we're going to describe the technologies that are needed to build cloud-native apps. And after this talk, every one of you will understand the key cloud-native concepts and will know how to get started with microservices. The topic cloud native has been around for quite some time. The first time I had to do with it was 5 years ago. It was shortly after I started to work in a new team, a team of developer advocates, and we worked on cloud-related technologies. To be honest, at that time, I didn't know much about cloud computing, which is why I had to learn a lot of new technologies. One of my colleagues was actually a much younger developer. And he told me that in order to build cloud-native applications, you need to build modern applications, you need to use microservices, containers, DevOps, and other technologies that I didn't know. And don't get me wrong, I like to learn in general. But at that time, I felt overwhelmed, and I had too little time to learn everything. Now, and I think that's why I came up with reasons why cloud native does not make sense. For example, I try to convince myself that cloud native is only useful for very few scenarios, that it's way too complicated and probably just another temporary hype. Now, when I was preparing this talk, I told my family that I want to share this story with you. And just a couple of days earlier, we had watched the movie The Croods, which is one of our favorite movies, and all of my children love it. And my family told me that you were like Grug in that situation. Now, for everyone who doesn't know the movie The Croods, Grug is the father of a family who lives in a cave in the Stone Age. And in order to protect his family, he teaches his children never not be afraid. In other words, be afraid. And he tells them that everything new is bad. Now, I have to say that my family was right. In that situation, I behaved like Grug. I considered the new microservices to be bad without really understanding them. Now, keep this story in mind. I will get back to it later, and I will tell you how it ended. But now, let's fast forward to today. It turned out that cloud native was not a temporary hype. In fact, the topic is more relevant than ever. And in the meantime, I've been able to work with microservices. In fact, Harald and we have developed an example application that shows how to get started with microservices. And that application we're going to use throughout this session for our demos. And we have open sourced this example so that every one of you can run these demos yourself on your notebooks after this talk. Okay, so let's get started with the definition of microservices. This is the definition from Wikipedia, and I think it's pretty good. Microservices are a software development technique that structures an application as a collection of loosely coupled services. In other words, you break down complex applications into smaller and simpler microservices. And this technique is really the core concept for cloud native. So, what are cloud native applications? Not every application that you deploy to the cloud is cloud native. Let's take an example. When you use an existing application and you put it into a virtual machine and deploy the VM to the cloud, that doesn't make the application cloud native. Instead, cloud native applications are applications that really leverage the advantages of the cloud. For example, scalability. But there are other good reasons to write cloud-native applications. And one is elasticity. That means that your applications remain responsive even when single microservices are not available. And similarly, you can continuously deliver new functionality because you can update the single microservices independently from each other. So, good news, there are many new options and possibilities for us as developers, but that also means that we as developers, we have to understand these options and new possibilities. We have to understand the advantages, disadvantages, and etc. And as illustrated on the slide, when there are multiple doors, we need to decide which door we want to open and go through. And also, new options often lead to new challenges. And here's an example. When you break down a complex application into microservices, for example, if you have a service A that wants to invoke a service B in a distributed environment, what happens when the service B is not available because the network is down? Okay, so after this quick introduction, let me now be more concrete and let me describe how exactly to build your first cloud-native applications and your first microservices. The first thing you need are images and containers, because that's how microservices are packaged and deployed. And here's the definition of a container image from docker.com. A container image is a lightweight, standalone package of software that includes everything needed to run an application, or in our context today, to run a microservice. And at runtime, these containers run isolated in their own sandboxes so that they don't interfere with each other. Let me get back to the story about Grug, because as I said, Grug, he preferred to stay in the cave in the movie, but at some point in the movie, the cave was destroyed. And that meant that he and his family had to learn how to live outside of the cave. In other words, they were forced to learn something new. And that actually mapped to my situation a couple of years ago, because as a developer advocate, I was no longer able to ignore microservices. I had to learn them. And I think Grug has a good point here, because he now, after he left the cave, he wants to become a microservices developer. And he wants to know what containers are in a way that he understands it. So let me try to explain again what containers are, and let me give you a concrete example for how to define and how to build a container that runs a Java application. Easy enough so that even Grug, as a caveman, can understand it. So the big advantage, the key benefit of containers is the portability. And as you probably all agree, naming can sometimes be challenging for us as developers. But in this case, the name container is really good. Everything you need to run an application or a microservice, you put in one box. The operating system, the application server, the application itself, and all of its dependencies. And that really addresses a problem with classic architectures, where you typically deployed lots of applications on one big application server. And that led to huge management overheads, and it slowed down the updates. With containers, you put everything again in one box, and that means you can ship these containers easily to other environments and run your microservices in these other environments. And I think that's a brilliant concept. Okay, so now let's take a look at the code. It's very, very simple to get started. This is the Docker file here in the right column, and that's all you need to do, 3 lines of code. Now, I'm a big fan of open source, and that's why we've used here a stack that is fully based on open source components. Okay, number 1, the virtual machine. As the virtual machine, we are using OpenJ9. OpenJ9 is the VM, the Java virtual machine from IBM, and we are using it in hundreds or thousands of offerings and services. In other words, it's enterprise proven. The other nice thing about OpenJ9 is that it requires 60% less memory than Hotspot. And the startup time is 40% faster than Hotspot. In other words, the JVM OpenJ9 is a great fit for container workloads. And the reason, by the way, is because it was originally designed to run on really small devices. The next component here in the stack is OpenJDK. I'm using an OpenJDK from Adopt OpenJDK. One advantage is that it's free. The other advantage is that you even get security updates, free security updates of a particular JDK, even after 6 months of the initial release. The next component is OpenLiberty. That's the application server I'm using here, and that's the open source version of WebSphere Liberty that comes with MicroProfile. And I'm going to describe and introduce MicroProfile a little later. So now, again, let's take a look at the Docker file. Only 3 lines of code. The first one says, extend an existing OpenLiberty image. Right? And this image comes with the exact stack that I just described. The only other things you need to do here is to add 2 more images onto the 2 more files onto the image. The first one is the server configuration, and the second one is the WAR file that contains the implementation of your microservice. So really simple to get started. Now, next, Harald will introduce Kubernetes to explain how to run these containers.
Okay, we just learned that a cloud-native application means to split your application into multiple microservices. So we have more than one service, more than one container. That means we need a tool to deploy those services into containers, to scale them, and to keep them alive. That's container orchestration. And one of the most widely used tools for container orchestration is Kubernetes. It's open source, it's the de facto standard, and it's used by basically all big public cloud providers, including IBM. It's also used to provide cloud capabilities in your own data center, maybe in the form of Red Hat OpenShift or IBM Cloud Private. So Greg has a point. If a container contains everything I need to run a microservice, why do I need Kubernetes? Well, in a microservices architecture, we have more than one service. Eventually, we have more than one instance of a service. So we need something to help keep this alive. And if we look at our example, you will understand that. This is our example application, or it's the front end of our example application. It's a typical web application running in a browser, written in Vue.js. It lists a collection of our blog articles, and for every article, it lists the title, the author's Twitter link, and a link to the author's blog. Very simple. And that's very simple, the architectural diagram. We have the web app in the browser that we just saw, and it sends REST requests to a web API running on Kubernetes, a web API service, which is a backend for front-end pattern. And the web API service retrieves the articles from an article service and the author details from an author service. So we already have 3 services that need to be deployed into containers and that need to be alive for our application to run. That's what Kubernetes does. Kubernetes also helps the web API service to talk to the articles and the author service without knowing any details, like on what node are these services running, what's their IP address. Kubernetes does service discovery for us. And here, on the right-hand side, you see some sample code from the web API service written in MicroProfile Java. And in the first highlight, you can see that for the URL, for the REST service, we only need the name of the service authors, plus, of course, the port number and the URI of the endpoint. But Kubernetes does the rest for us by name resolution. In the second highlight, you see that in order to make the REST call itself, we simply call a method from the MicroProfile REST client library. It's like any other method call in Java. It's type safe, and Niklas will talk about MicroProfile in a moment. So another important tool for microservices architectures and cloud-native applications is Istio. It is open source, like Kubernetes itself. Istio provides something called a service mesh, which is a transparent layer on top of your distributed application. Istio helps us run a microservices architecture, and it provides ways to control the data flow, to secure the data flow, and to monitor the services. It does so by using proxies. They are called Envoy with Istio, and the envoys handle the communication and the data flow between the services. This allows us to use a service mesh without adding additional code or libraries to our services, and it also helps us to implement polyglot microservices. It's language independent. So another good point from Grug, why do we suddenly need a service mesh? And I think that's easiest explained with another example, with a typical Istio example. Istio has many features, many cool features, but one of the really good ones is traffic management. We know dark launches, canary deployments, A/B testing. We introduce a new service and we want to test it on a limited set of our users. In our example, you can see that we now introduced a version 2 of our web API. They are very similar to each other. This is version 1. It displays 5 articles, and version 2 displays 10. No big deal. It's a simple example. If I could refresh the browser now, you could see occasionally version 1, occasionally version 2. So if we use Kubernetes alone, we would do a rolling release, which means we would deploy version 2 and Kubernetes would start version 2 and stop version 1. If something goes wrong, we roll back, Kubernetes stops version 2 and starts version 1. That's not a lot of testing. There are other ways, there are ramp deployments that can do something similar, but not as simple as Istio. With Istio, we deploy both our versions at the same time. We label them version 1, version 2, and then we create a virtual service with a rule. You can see it in the highlight, and the rule says we direct 80% of all requests to the get multiple endpoint through version 1 of the web API, and 20% go through version 2. And this is how it looks like. This is Kiali, this is the dashboard for Istio. And in the graph, you can see that of all requests that go into the web API service, 80% go to version 1, 20% go to version 2. The graph is built dynamically, so we see all the other services that make up our microservices architecture, plus we see a lot of statistical information like requests per second, and do we have any errors.
Okay, cool. So the next technology.
No.
Okay, the next thing I want to talk about is MicroProfile. The two technologies that Harald just introduced, Kubernetes and Istio, are generic platforms that you can use to run all types of microservices, no matter how they have been implemented. However, for certain microservices functionality, that's not sufficient. The generic platforms cannot handle everything. In some cases, you need to implement business logic in your microservices. And that's exactly where frameworks, language-specific frameworks like MicroProfile come into play. And again, I think Grug has a good point here. He learned quite a bit already today. So let's keep it simple and let me give him and you a simple example that explains why and how you would use MicroProfile. The sample I want to use is resiliency. Again, this is our sample application with the 4 components. What I want to show next is how the web application and the web API service can remain responsive even when both the article service and the author service are not available. As I said, this needs to be done in the code, in the business logic. And this is the implementation of the web API service, specifically the implementation of the API that returns a list of articles. The snippet here at the bottom shows how to handle the case when the author's service is not available. Rather than not returning anything, the list of articles is returned, but simply without author information. The next snippet here shows how to handle the case when the article service is not available. In this case, an exception is thrown and a MicroProfile API functionality is used called @fallback, so a new Java annotation. And this fallback annotation kicks in when an exception is thrown. In other words, another fallback method is invoked. And in our case, that means that this fallback method simply returns the articles that were read the last time the article service was available. In other words, this information is simply cached. And here's how it looks in the UI. This is the fully working web application when all services are available. As soon as you shut down the authors service, the information about the authors, the links to the Twitter profiles and the blogs disappears. But at least you are still able to see the list of articles. And even when you delete or shut down the article service, you would see the same UI, the same list of articles, because again, this information has been cached.
So he already thinks like a developer. We have the situation, we no longer have a monolithic application, so we no longer have a single log file where to look into if we have problems. So with microservices architectures, we have more implications that we need to be aware of as developers. This leads us to observability. We are in a dynamic environment where objects come and go. For example, if you have a very active Kubernetes cluster, Kubernetes may stop a pod on one worker node and restart it on another worker node just to spread the load over the cluster. So as developers, to observe our application means we need to observe moving targets, which means we need different tools and new tools. We need distributed logging. We need distributed tracing because our requests pass through many different services. We need monitoring and metrics. So thinking about distributed logging, we have three services that run in 3 different pods, in 3 different containers that create 3 different logs. If something goes wrong, we don't want to look in 3 or more different places. We want to have a single place to look at, and that leads us to distributed logging. And one of the examples of distributed logging is LogDNA. That's the logging service we use on the IBM cloud. It integrates extremely well with Kubernetes because the LogDNA agents are deployed as a daemon set in Kubernetes itself. They run on every worker node. They collect everything that can be collected in the cluster and presents it in a single place. This is actually an interesting setup. Niklas said we try to run everything on Minikube. So this is a LogDNA service running in a cloud data center in Frankfurt, and it is connected to a Minikube running on my notebook in Stuttgart, which works as well. And in this example, in the headline, you see I filtered on 4 apps. These are the 4 apps that make up our sample application. And in the highlight, you see log information coming in from articles, from Web API, and from authors. So let's create a problem. I killed the author service. I had simply deleted the author's deployment. And when we look into LogDNA, into the dashboard, we immediately see there is a problem. We see that the Web API is still able to talk with the article service, but it doesn't get a connection to authors. We also see no entry of the author service, so maybe it's down.
Okay. All of the samples, all of the demos from today are available as open source. You can find the link to the repo here in the lower right corner on the slide. We will also display a QR code on the last slide of this talk that points to the same repo. Harald and I, we've spent a lot of time to make the first time experience of this example as easily as possible. As I noticed the other day, we actually wrote more lines of code for scripts than actual Java code. For example, for every service, there's a script to deploy the service, to delete it, to see the logs, etc. We've documented how to run this example locally on Minikube. And even if you haven't set up Minikube yet, you should be able to do so and set up the complete sample application in less than an hour. So I think for everyone who wants to get started with microservices, this is a great starting place. And here's the architecture of the complete application. There are several other services and components, for example, to do authentication, authorization, observability, and persistence. If you want to find out more about those topics, again, go to our repo. There's a documentation section, and we have also written a series of 20 blog entries about it. The other thing I want to point out here is that the core components of this example are all available as open source. In other words, everything that you see here in the two left columns. The cloud services in the right column are not available as open source. However, they are only optional, plus you can easily exchange them with other implementations. For example, for the persistence of the article service, we use JPA, and that obviously allows you to switch easily to another SQL database.
Okay. I think we pointed out that we created the Cloud Native starter around open source and made it run on Minikube so that everybody can start with it easy and simple. But we both work for IBM. IBM has a cloud, and on this cloud we have a managed Kubernetes service with a managed Istio. And if you like to try something that's even newer than that, there is even a managed Knative. So in the GitHub repository, we have all the information you need to run the example on the IBM cloud. And you can do that very easily because there is something called a light account for the cloud. You can register for it. It's free. It doesn't require a credit card. It doesn't expire. What's even more interesting, if you come to our booth downstairs in the expo area, you can get cloud vouchers like these with a code with which you can unlock additional features like access to a free Kubernetes cluster to test this for a year. So if you want, try it.
Okay, just to wrap it up really quickly. As you know, at the beginning of the movie, The Croods, Grug taught his children never not be afraid, and he told them that everything new is bad. As I said, at some point in the movie, Grug and his family had to leave the cave, and they had to learn how to live and survive outside of the cave. But not only that, they also appreciated the advantages of being able to live outside. So at the end of the movie, Grug doesn't tell his children anymore, never not be afraid. Instead, he tells them the exact opposite, never be afraid and try out new things. I hope that in this talk we demonstrated that cloud native is no magic, it's not as complicated as some might think, and everyone can learn it. Thank you.
Thank you.